Today's lesson is going to be factoring, grouping, complete the square, or the quadratic formula. So we're going to solve single variable quadratic equations using one of the following methods: factoring, grouping, complete the square, or the quadratic formula. Cornelius? Perry?
Oh, he right there.
Mr. Perry? To M office, Waddell?
We have the right to keep it.
Okay. This is just a header for the notes for today. You don't need to write the header. You're not going to get a classwork on the header. I need you to write down the problems. That's what's most important for you. But these are, of course, just going to be a professional record of what we did in class today. Okay? So we completed 1 through 6 on Friday. And we're going to pick up on number 7 today.
Number 7.
R squared plus 5R is equal to 14. The steps. Put it into general form.
I promise you this gonna be.
So we're going to subtract 14 from both sides. And now we need to determine which method is going to be the easiest to solve this.
Oh, the X right there. 7 and 2. -7.
The quadratic formula.
So,
What would we call the X? I forgot.
so there's factoring, there's grouping. We want to solve the quadratic equation, this one by grouping. So what we are looking for is two numbers that when we multiply them together, we get -14, and when we add them, we get 5. So R plus 7 times R minus 2 is equal to 0. This is called the zero product principle. It says that when two things are equal to 0, one or both of those must be 0. And so what we do is set them both to 0 and solve for the variable. These are possible solutions. And now we're going to test our possible solutions. So negative 7 squared plus 5 times negative 7 minus 14 is equal to 0.
I think you're wrong. It's not a solution.
So we have 49 minus 35 minus 14 is equal to 0. That is true. So r is equal to negative 7 is a solution. And now we'll test 2. So r is equal to negative 7 and r is equal to 2 are both solutions. And we're finished. So over here on the side, what I'm putting here, it's the algorithm, or it's the set of procedures that you'll use to solve this type of problem. And it will always be the same. Always be the same. For any quadratic equation. Let's look at number 9. So I'm not going to write the steps. I'm not going to write that algorithm every single time. But what's the first step we do in the algorithm? General form. Put it into general form, okay? So minus 288 minus 288 on both sides gives us minus 8x squared minus 0. Now, I just want to make a comment that in math, it's extremely important to distinguish between the objective and how to accomplish the objective. The objective is to put this into general form. That's the first step in the algorithm. Now, how we do that is by subtracting negative 288 from both sides. It seems elementary, but it's really important, because to know that you're putting this in general form is a conceptual thing. Knowing how to do that is mechanical. It's procedural. There's always those two aspects of mathematics going back and forth. Do you conceptualize what you're doing, and are you actually able to mechanically or procedurally do it? So general form would be the conceptual aspect, and minus 288 would be the procedural or mechanical aspect. Now from here, what can we do? We want to determine the next step in the algorithm is what? Choose a method. So from here, well, we don't see any single x's, and I'm just going to put this out there. For now, whenever you are confronted with a quadratic equation on a test, on this test coming up, or anything, you can always solve it using the quadratic formula. That's not always the most time efficient, but I would say unless you love to do complete the square and you really are good at doing that, avoid using complete the square when you can, which means probably don't choose that method of solving a quadratic equation. Okay? So on this one here, do we want to factor, do we want to group, or use the quadratic formula? Essentially, that's the question. Let's factor something out first. And so what can we factor out? Negative 8. So we'll factor out a negative 8. That's going to leave us with x squared plus 36 is equal to 0. Now we are at the zero product principle. Well, we know that negative 8 is certainly not equal to 0. So we just leave that. But what we can do now is we know for sure by the zero product principle that x squared plus 38 x squared plus 36 must be equal to 0. That's just logical, right? Because if a or b is 0 and a is not 0, b must be 0. So x squared plus 36 is definitely equal to 0. So now we just go through this like we would. X squared is negative 36. We're going to take the square root of both sides. So x squared times 1/2 is equal to negative 36 times 1/2 in the exponent. This cancels out, and we're left with x is equal to plus or minus the square root of negative 36. Any number a to the 1/2, in this case a is negative 36, but any number a is always equivalent to plus or minus the square root of a. So that's how I'm going from negative 36 to the 1/2, and then I'm getting plus or minus the square root of negative 36. It's just an equivalence of exponents. We know that the square root of negative 1 is equal to I. So we can essentially parse out that negative 1 if you really need to. And then what we have left is I in the square root of 36 plus or minus 6I. The square root of 36, the negative 1, I'm separating 36 from negative 1 because negative 36 is equivalent to negative 1 times positive 36. So I just rewrite what's underneath that sign because that allows me to see that I have a square root of negative 1, and I can just pull that out. Okay? And we're done. So this is the answer. So x is equal to plus or minus 6I. It's not just plus 6I, it's also minus.
Hold on, let me get through this one part that I mentioned up on.
Number 11. What's the first step in the algorithm? It's general form. That's the concept. And of course, how do we get there? Subtract 52. What's the easiest method to use when we start seeing coefficients in front of our leading term? Quadratic. When you guys start seeing any coefficient greater than 1 in the leading term, quadratic formula right away. If I see a 1 out in front of this x squared, or if I only see x squared by itself, I always, 100% of the time, look to see if I can factor it or group it. As soon as I see a coefficient there, I'm like quadratic formula immediately. So we're going to use the quadratic formula on this. I'm going to make a little note here for you and say it's not always 100% of the time, but I'd say 99-point-something% of the time, if you see a coefficient greater than 1 in the leading term, just use the quadratic formula. So in this case, we clearly have something greater than 1. It's 2, and we're just going to use that quadratic formula. So we know that the quadratic formula is and so what's our A?
2.
And C is
Negative.
negative 52. And so we're going to, X is going to be equal to minus negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times negative 52. All of this is over twice 2 times 2. And so now we can number crunch this. And let's see if we get a negative underneath the radical. Let's just get that far. So x is equal to 5 plus or minus the square root of negative 5 squared, so 25, minus 4 times 2, which is 8, minus 52. So 8 times negative 52 over 4. So x is equal to 5 plus or minus the square root of 25 plus 416. Over 4. And I'm gonna stop at this point here because it's just number crunching. But just take it as far as the test or whatever wants you to take it number wise, okay? You guys can all handle it from this point here. Remember that you're going to have a plus and a minus version. And it's going to be important for you to do what?
Look at the coefficient.
Number 4,
Test possible solutions.
test the possible solutions. Test them. So choose a method, put into general form, choose a method, solve for the variable, test the possible solutions, and then determine what they are. So from here, the next steps would be test the possible solutions. And then determine the solution or solutions. And let's go ahead and do number 10. Let's do number 10 quickly here. I know this is backstepping, but we could probably finish this in just a couple minutes, and then I can check classwork here. So number 10 is (36n squared is equal to 81). General form is always the first step that we want to do. So we're going to put 36 Is there something we can factor?
36 and 81.
A 9.
18.
Can we factor a 9?
18.
So let's factor out a 9, right? We always want to look to see if we can factor. Then we want to go up to grouping. Then we want to think about the quadratic formula. Factoring, grouping, quadratic formula in that order. So 9, so this would be 4n squared minus 9 is equal to 0. Well, of course, the zero product principle now. Well, certainly 9 is not equal to 0, so we just get rid of 9. And we set 4n squared minus 9 equal to 0. And I want to do something, I want to use the difference of two squares. So how I want to write this is 2n squared minus 3 squared is equal to 0. (2n squared minus 3 squared is equal to 0. And then I can push the 3 squared on the other side. So I can push the 3 squared to the other side so that I have 2n squared is equal to 3 squared I could take the square root of both sides. And then I'm left with 2n is equal to 3. Plus or minus though, right? Always plus or minus. N is equal to plus or minus 3/2. There's a couple of different ways that you could have done this. You guys can go back and think about this. I wanted to incorporate this here because later on in the course, you're going to start seeing where you're going to have to recognize that a number is a perfect square. And so that's why I did this, because we can clearly recognize that 4n squared is a perfect square of 2n, and that 9 is a perfect square of 3. And then go through, and I also allowed you to be able to reuse taking the square root of something again, because that came up in an earlier problem today. And so just a little bit more practice with taking the square root of something to undo a radical there. And so we will finish here today, and I will start checking your classwork.